Welcome. Today we are going over 5.4b notes. Again, normal distribution, empirical rule, and z-score. Today we're going to focus more on the z-score part. So all situations and examples we're going to assume are a normal model. Okay. So if we knew the mean score, the average score of the test was 87, and the standard deviation was 4. Alright, so that's what we know. A student scored a 91 on the test. Would be exactly blank standard deviations. So if the average is 87 and they scored a 91, how many standard deviations are they from the mean? They're exactly 1 standard deviation above the mean. Their z-score would be, right, z equals 1. So their z-score is how many standard deviations they are from the mean. Now they could be above it or below it, but their z-score is how many standard deviations from the mean. So a score of 91 is exactly 1 standard deviation above the mean, so their z-score is positive 1. But what about a student that scored a 97 on the test? What would the z-score be for that student? Well, okay, if you add, right, 91 was exactly 1 standard deviation. 95 would be 2 standard deviations. 99 would be 3. Okay, so we don't know the exact z-score. It's somewhere between 2 and 3. Because a 99 is 3 standard deviations, 95 is 2. So it's somewhere between 2 and 3 standard deviations. Well, I want the exact number. And that number is what we call their z-score. So there's a formula we're going to use. So this is the z-score formula. All right. This is something that will be given to you. You don't have to memorize it. But this helps you determine, right, the student's z-score. This tells you how many standard deviations are above or below the mean. So again, the z-score is how many standard deviations from the mean. So if it's a positive number, it's above the mean. If it's a negative number, it's below the mean. Okay, so let's calculate the 97. So notice there are 4 letters there. This is the z-score. Right? Right? X equals the data point. Right? Mu is the mean. Sigma is the standard deviation. So to find the z-score, the data point in this case is the 97, right? The mean is 87, and the standard deviation is 4. So again, mu, the average was 87. Sigma, the standard deviation was 4, and x, the data point, was the 97. That's all in the information above. So now I'm going to calculate that. So you get 10 over 4, right, which is 2.5. So the z-score is 2.5. So what does that mean? That means a score of 97 is 2.5 standard deviations above the mean. You can't just say from the mean, because technically, yes, it is from the mean, but you could have negative or positive. So you must make sure you state whether it's above or below the mean. It's above because it's a positive number. If it's a negative z-score, it's below. Positive is above. But you must state whether it's above or below the mean. Because if you just say it's 2.5 standard deviations from the mean, well, that could be above or below. Right, so using the same information, so your average is 87, standard deviation is 4. Calculate the z-score for someone who scored 80. So mu is 87, sigma is 4, x is 80. So using the z-score equation, it's x minus mu divided by sigma. Right, going to be very important. Anytime you see z-score, you write that formula. So in this case, we have 80 minus 87 over 4. Right, negative 7 over 4, which is negative 1.75. Okay, so what does that mean? That means a score of 80 is 1.75 standard deviations below the mean. Again, you must state whether it's above or below. It's 1.5 standard deviations below because it's a negative 1.75. Now, why did I not write negative 1.75? Why did I not have the negative? Because by saying below, that tells me that my z-score is negative. I don't have to write it. The z-score just tells me how many standard deviations I'm from the mean. So negative means I'm below it. Positive means I would above it. So when I write what the actual z-score represents, I shouldn't be putting the negative or positive. That comes from the above and below part. So that's why it's important that you have below and above. Right, so a Colorado ski resort and Lake Tahoe, right? They're talking about Christmas and New Year's. They record how much snow they get. So Colorado reports 88 inches. Lake Tahoe is reporting 74. Okay, so the average and standard deviation are below. So for Colorado, you have 78, right? That's your mu. This is your sigma, right? This is your mu. This is your sigma. And for x, right, it's going to be 88 for Colorado, and for Tahoe, it's going to be 74. So which resort had more snow during the holiday season? Relatively speaking, we'll use the z-score to help us. So remember, the z-score formula is x minus mu over sigma. So we're going to do a z-score for Colorado. And we're going to do a z-score for Lake Tahoe. And then we're going to compare them. Okay, so for Colorado, right, our z-score, our x is 88 minus 78, our mu over 8. So 10 over 8 is 1.25. Okay, Lake Tahoe, right, our z-score is x, which is 74, minus 60, divided by 10. So 14 over 10 is 1.40. So we have our z-scores, right? Remember, that's how many standard deviations from the mean. So both of them are above average, right? 1.25 standard deviations above the mean for Colorado, 1.4 standard deviations above the mean for Lake Tahoe. So relatively speaking, which one had more snow compared to their average? Okay, how do we determine that? Well, compared to the average, the number that's further away from the average, that's above it, means you got more snow relative to their average. So since Lake Tahoe has the larger z-score, relatively speaking, they got more snow. So Lake Tahoe had more, relatively speaking. Now, physically, yes, Colorado technically it does have more snow, right? 78 or 88 versus 74. But compared to their averages, Lake Tahoe is further above the average than Colorado is. So, relatively speaking, based off of their averages, Lake Tahoe would have more snow. All right, let's go to the next one. So, if a neighborhood where the size of the average house is 2,100 square feet, the standard deviation is 80 square feet, what is the size of the house with a z-score of 1.3? Okay, so they're giving me a z-score. Okay, this one's a little different. We haven't had one like this. Okay, so as soon as I see anything with z-score, I'm going to write the z-score formula. Okay, now notice there are 4 different variables there, z, x, mu, and sigma. I can ask you to find any one of those 4 if I give you the other 3. So on the front side, we were finding z every time. So now this time they're giving us z. So z is 1.3. Okay, the average, so this is mu, is 2,100. And then this is sigma, the standard deviation. So in this case, I don't know what x is. Right? I'm trying to solve for x. So before on the front side of the notes, I was solving for z. Now I'm solving for x. So I just have to solve for x. Right? So we can put this over 1, cross multiply. Right? 80 times 1.3. Right? That's 104 equals x minus 2,100. Add 2,100 over. So x equals 2,204 square feet. So put it over 1, cross multiply, added 2,100 over. So I get 2,204, right? 2,204 square feet. Okay, in the same neighborhood, what is the size of the house with a z-score of negative 2.1? So again, you give me the z-score, I'm going to write the z-score formula. So same thing. This time I know the z-score again. I know it's still the same standard deviation, and it's still the same average, so 2,100. So again, I'm trying to find x. Right? This is my z-score. I'm still using the same sigma and the same standard deviation, or the same average. So exact same problem, just a different z-score now. So same idea, right? Put this over 1, cross multiply. You get negative 168 equals x minus 2,100. Add 2,100. You should get 1,932 square feet. Now, do my 2 answers make sense in my problem? So I have a z-score that's negative. So that means you're below the average. Well, the average is 2,100. So it makes sense that I got 1,900 because that's below the average. And the first problem, the 2,204, my z-score, right, was positive 1.3. So that makes sense that my answer should be above the average. So it should be bigger than 2,100 square feet. In this case, it was 2,204. So your answers still should all make sense. Negative z-score means you should have a number less than average. Positive z-score means you should have a number above the average. Right, this last problem, it's kind of a challenge problem. So if you want to attempt it, please give it a shot, try it. I will let you know, right, that if you do it right, you should get 9 for the average. And the standard deviation is 1.2 if you do it correctly. Again, it's a challenge question, so if you want to give it a shot, great. If not, you can skip it. So again, going back, z-score, right? That's an important formula, right? It's you're gonna need to be able to use. Again, you won't have to memorize it, but you need to know how to use it, right? There's 4 variables. You have to be able to solve for any one of the 4. You have to have your x, your data point, mu, is your mean, sigma is your standard deviation, and z represents the z-score. What is a z-score? How many standard deviations from the mean? Positive means positive z-score is above the mean, negative z-score, you're below the mean. Again, this is all based off the fact that we have a normal model. If we don't have a normal model, z-scores don't work. So please make sure you answer the essential question, right? Write your summary at the very end, answering that essential question, and then you'll be done with your notes. Have a great day.